Hi, Sarah. Watch out! Don't come closer.
What's with all those wires? What's this? I see the sign a lot on the street.
The sign tells us there is electricity and it's dangerous.
What will happen if I go near it?
You know, the sign itself is not dangerous, but it says there is electricity here. You cannot come closer.
Why do we get shocked in the first place?
I'll tell you. For example, any plug of an iron or any device, it has two pins of metal. They go into the socket. Do you know why they are metal?
Why?
Because metals conduct electricity. For example, see this wire? These wires are made of copper, which is an electric conductor. It conducts electricity from the socket to the device.
Why is it covered with a cord? To look good? Decoration?
Not for decoration. The cord is very, very important. Just like there are good conductors, there are insulators.
What do you mean by insulators, Grandpa?
The insulators never conduct electricity, like plastic, wood, glass, rubber. So this copper wire should be coated to insulate electricity. If it is not covered, anyone touches it will be shocked. It's coated for safety.
Ah, I get it now. When the electrician comes to us, he brings tools like that have handles made out of wood or rubber, so that he won't get an electric shock, right?
Yes, because it totally insulates electricity.
I also saw my mom putting a plastic piece in the electrical socket. When I asked her why, she said so my little brother won't put his fingers.
Right, for safety. If your brother puts his finger in the socket, he will get shocked. That's why your mom used plastic to insulate.
Does that mean that plastic stops electricity?
Exactly. It insulates. Now you see. Let me explain that using a small invention. Now listen. We will use a battery, okay? And all these things and make an invention.
What are all these stuff, Grandpa? These have nothing in common. A paperclip, wood, cloth. What's all this about? I can't get it.
I'll explain. Look. Now. We'll try something. Let's consider this battery the energy source. And its wire. Now let's test it on a various things. Just a second.
Grandpa, what did you do?
I'm doing something brilliant. Here, look, hold this wire.
Uh-huh.
And I will connect the two ends on one from here and the other from here.
Oh, it worked.
Yes, this is a closed circuit. Now, let's try something else. Leave this wire and take this paper clip. Let's try again. We'll get the paper clip and put the end of the wire here and the other end there.
It worked again.
It worked again. Then the circuit is still closed. Now, would you try it?
Yes.
Try it. We'll connect this end here and the other end there. Now, did it light up?
No, it didn't light up.
Okay, let's try this piece of cloth. Fold it. We will connect it like this and this. What do you think?
Still no light.
No light means that those good conductors of electricity closed the circuit. What about poor conductors?
They block the electric circuit.
You got it.
What else is good conductors of electricity?
Water. Water is good conductor of electricity. That's why we never bring water close to any electricity source. Also never plug a wire or unplug it with wet hands.
Are our bodies good conductors?
Yeah, I'll tell you a very interesting fact. Do you know that around 70% of our body is water and it conducts electricity? So if we touch electricity, our body will work as a good conductor.
What do we feel when we get an electric shock?
No. It's a terrible feeling. Once I was working with electricity, making one of my inventions. As I was approaching one of the wires, I didn't notice that it's exposed. As I touched the wire, I started shaking and fell to the ground. Add to that, I was standing on a puddle of water, an exposed wire, all good conductors. It was horrible feeling.
And then what happened?
Grandma found me on the ground shivering from the shock. She got a wooden chair and pushed me away from the electric source. So I was saved that time.
Oh, it's the wooden chair. She had to use a material that insulates electricity.
Of course, or else you would have been shocked too.
Then what?
Since that happened, whenever I come close to electricity or do something related to it, you know what? I wear those plastic boots like workers and pay attention to all the warnings.
Grandpa, I want to help you.
Okay, will you be careful?
Yes.
Okay, now look. This is what I want you to do. I want you to take that plug out of the socket so that I would know where is the end of this wire. Sarah, what are you doing?
I'm holding the insulated part.
No, Sarah, that's so dangerous. Pulling it like that many times, it might make the insulated part cut from here. So when someone tries to put it in the socket or touches it and the wire is exposed, he'll get shocked.
Got it, Grandpa. I'll unplug it correctly, not from the metal part, to avoid the shock.
Well said, Sarah.
We learned today about the dangers of electricity and how to be safe around it. There are materials that are good conductors of electricity because they allow electric current to pass through them, such as metal and water. But thankfully, there are insulators of electricity which do the opposite job of conductors. They are materials that do not allow electricity to pass through. We must remember that our bodies are mostly water, making it easy for electricity to pass through us. That's why, if we're not careful, we can get an electric shock. If someone does get an electric shock, you should help using an insulator like wood or plastic to stop the electric current from passing through your body as well. And never forget to wear plastic or rubber boots when you're dealing with electricity. The insulators will stop the electricity from giving you a shock.
Would you grab me the toolbox from there so that I can finish this invention?
Okay, Grandpa.